In this video, we are going to learn how to factorize polynomial and algebraic identities. Okay, so suppose we have a monomial. Okay, polynomial consisting one term. Suppose monomial. Suppose 10 x to the power 5 y to the power 3. Then how to factorize it? So let me show you how to do. 10 can be factorized as 2 5 is 10. Then x to the power 5 means x into x into x into x into x. Okay, 1 2 3 4 5. Then y to the power 3 means y into y into y. That's how we can factorize a monomial. Okay, now let me show you how to factorize. Suppose we have a binomial. Suppose 9x cube y square plus thrice xy. Okay, here you see how to factorize this. First, now you see this term can be written as 3 into 3 x into x square, then y into y. Okay, y square means y into y. Okay, so, and here x cube can be written as x into x square. Okay, 9 can be written as 3 into 3. So hope you have understood this. Then here you see the next term is thrice xy, so 3 into x into y. Okay, and also you can write into 1. Okay, now from these two terms, compare these two terms, what you can take common from here. Okay, you can take thrice xy, thrice x and y. Okay, common. Then so what we have taken here, thrice xy common. Then what are the remaining terms here? So on taking thrice x common, what are the remaining terms we have got here? 3x square y, 3x square y plus 1. Okay, so it's very simple. Let me explain again. So what we have done here, you can see this 9 can be written as 3 into 3 and x cube can be written as x into x square. Okay, what is the reason behind it? This term is thrice xy, so here x to the power 1, so that's why I have written 1 x to the power 1 into x to the power 2. X means x to the power 1. Okay, so now y square can be written as y into y. Okay, then this can be written as thrice x into y into 1. Okay, 3 ones are 3, again you will get 3. Okay, now from here what we have taken common, we have taken thrice xy common. Here you see, if you compare both the terms, then you can see this 3 is present in both the terms, and x is also a factor of both, and y is also a factor of both. Okay, now what we have taken, thrice xy common, this one, so this is thrice x and y. Okay, so let me erase the common part now. So this is the common part I have cleaned. Okay, then what are the terms left? Thrice x square y, then it is 1. Okay, so that's how we can factorize a binomial. So hope you have understood this. Okay, so this is the result. Okay, so this is our result. So now let me show you another example. Suppose we have thrice x square plus xy. Now how to factorize this? Now you see first term can be written as 3 into x, and the second term simply you can write x into y. Okay, in these two, what is the common factor you can take common? Okay, So common factor means which is present in both the terms. So here this consists x here. So x is the common term. Okay, x is present in both the terms, so that's why x is the common factor here. So let us take x common, then write the remaining terms within bracket. Okay, so what are the remaining terms? So here, from here we have x taken, we have taken common x, and from here also we have taken x common. So remaining terms are thrice x plus y. Okay, that's how we can factorize it. Okay, hope you have understood this. So let's move on to another example. Suppose we have a trinomial. Okay, we have a trinomial thrice x square, okay, plus 5x plus 2. Okay, so here you see how to solve this. Okay, first in this case, in such polynomials, what to do? Here you can see there is no any term which is present in all the three terms. Okay, there is no any factor which is present in all the three terms, but we need to factorize this. How to factorize this? So let me show you. So first of all, what to do? We need to multiply the coefficient of x square and the constant term. So this is constant and this is coefficient of x square. Okay, so multiply these two. 3 into 2, that is equal to 6. Okay, that is equal to 6. Then here you see we have to find two factors of 6 such that either their sum or difference is equal to 5. Okay, that means the coefficient of x. Okay, so here you see we know 3 plus 2 is equal to 5. So that's why we can use the 3 and use the factors 3 and 2 of 6. Okay, so that's why what to do here, this middle term can be split as, so thrice x square 3 plus 2. Okay, this is called splitting the middle term. Okay, splitting the middle term. Okay, plus 2. Now thrice x square plus 3 into x is thrice x. Okay, then and 2 into x is twice x. Okay, plus twice x plus 2. Now you see from these two terms we can take x common, okay, and 3 common. Okay, not only x, we can take x and 3 common. Okay, so let me show you how. So here you see thrice x square can be written as 3 into x, and thrice x can be written as 3 into x into 1. Okay, and from here what you can take common, you can see clearly thrice x can be taken as common. Okay, on taking thrice x, what are the remaining terms? X plus 1. Okay, so let us take thrice x common. Okay, so on taking thrice x, what we have got? So let me clean the terms which is taken common. Okay, so now we have got x plus 1. Okay, similarly from the next two terms, you can take common. Here you see twice x can be written as 2 into x, and 2 can be written as 2 into 1. Okay, that is plus. So clearly you can take 2 common from here. Okay, so 2 common, so that is plus here, so put here plus. 2 is taken common. After taking 2 common, what we have got? 2 is taken common, then we have got again x plus 1. Okay, x plus 1, x plus 1. Okay, so now you see in these two parts, compare these two parts, it is seen that x plus 1 is common in both. Okay, so let us take x plus 1 common. Okay, on taking x plus 1 common, so what we have got, thrice x and plus 2. Okay, so these two parts, this x plus 1 taken as common, okay, from both the terms. So that's how we can factorize such kind of polynomials. Okay, let me show you one more example of this kind. Okay, now suppose we need to factorize this polynomial. Okay, this is a trinomial. Okay, so how to factorize this? So let me show you again, let me explain this, how to factorize this. Now you see, what is the first step? Just multiply the coefficient of x square and the constant term, 6 and 5. Okay, 6 5 is 30. Then find two factors such that their sum or difference is equal to the middle term, coefficient of the middle term. Okay, coefficient of the middle term. So it may be sum or difference. Okay, now you see, 6 plus 5 is not equal to 13, and 6 minus 5 is also not equal to 13. So let me find other factors of 30. Okay, what are the other factors of 30? We know 10 3 is 30. Okay, 30 can be factorized as 10 into 3. Okay, and sum of 10 and 3 is equal to 13. That's how this middle term can be split as 10 plus 3. Okay, so that's how we can factorize. Okay, now let me show you. So 6x square, now split the middle term as 10 plus 3 into x plus 5. Okay, so here you see, now 6x square plus 10 into x, here we will get 10x, and 3 into x we get thrice x. Okay, plus 5. Okay, now you see, from the first two terms what you can take common. Okay, so here you see 2 3 is 6. Okay, 2 5 is 10. So clearly here 2 can be taken common, and x square can be written as x into x, and here is only one x is there in the second term. Okay, so from here you can take x also common. Okay, so we can take twice x common. Yeah, so from these two terms we can take twice x common, isn't it? So twice x. In the next, here you see thrice x, 3 into x, this is 5. Okay, there is no any common term other than 1. 3 into x into 1 you can consider, and 5 can be considered as 5 into 1. So only 1 is common. What are the remaining terms? Thrice x and plus 5. Okay, and from here you see, from the first two terms what we have taken common? We have taken twice x common. Okay, twice x common. Then what are the remaining terms? We have got here, on taking this common, twice x, so we have now thrice x plus 5. Okay, thrice x plus 5. Okay, and from here take one common, then what you will get again? Thrice x plus 5. Okay, thrice x plus 5. Now you can see thrice x plus 5, this is also thrice x plus 5. From these two you can take thrice x plus 5 common. Okay, this one and this one. Okay, then after taking thrice x plus 5 common, you will get twice x plus 1. Okay, twice x plus 1. So that's how you can factorize such kind of polynomials. Okay, so this is how you can factorize. Okay, let me clean this first. Okay, so this is the complete solution, how to factorize a trinomial of such types. Okay, now let us discuss about some identities, algebraic identities. Number 1, a square minus b square is equal to a plus b into a minus b. Proof. Take the right hand side, a plus b into a minus b. Now multiply these two. So how to multiply binomial by binomial already we have discussed, okay, in the last video. So a into a square, then again a into minus b is minus ab, then b into a, you can write ba, or ba and ab same, so instead of writing ba we will write ab. Okay, so b is positive here a is also positive. Okay, so sign is not mentioned, that means it is positive. Okay, then multiply this b with minus b, then you will get minus b into b square. Okay, so now here you see, first let me clean this. Okay, you can see this is minus ab, this is plus ab, so you can cancel these two. Then cancelling these two, you will get a square minus b square. This is minus b square, this is a square. Okay, so that is how we have got a square minus b square is equal to a plus b into a minus b. This is the left hand side. Okay, our next identity is x plus a into x plus b. Okay, suppose we have x plus a into x plus b, then what is the result of this? So x square plus a plus b into x plus ab. Okay, so this is one another algebraic identity. This is very useful identity. Suppose we have to multiply two binomials of this form. Suppose we have twice x plus 1 and twice x plus 3. Okay, so here you see, so if you check the pattern here you see in this identity first terms are same in both the polynomial, yes, and the second terms are different. So here also first terms are same in both the polynomials and second terms are different, they are not same. Okay, in this case you can apply this identity. Okay, compare this twice x with x, okay, and a with 1 and b with 3. Okay, x with twice x. Okay, then according to this identity you will get x square. Here x is twice x. Okay, twice x whole square plus a plus b. A plus b, a is 1, b is 3, 1 plus 3 into x. Here instead of x there is twice x, so twice x plus a into b, that is 1 into 3, 1 into 3, that's equal to 4x square. 3 plus 1 4, 4 into twice x plus 3 1 is 3, that's equal to 4x square plus 6x, sorry, that should be 8x. Okay, 4 to the 8, 8x plus 3. Okay, so that's how we can apply this identity in order to find the product of such kind of polynomials. Okay, so let me prove this identity. Okay, how to prove this identity? So let me show you. Now take the left hand side, x plus a into x plus b. Now multiply. So how to multiply? First you need to multiply the second polynomial by the first term of the first polynomial. Okay, x into x, then x into b, that gives x into x, x square, plus x into b, bx. Okay, then plus a into x, ax, then a into b, ab. Okay, so here you see from these two terms you can take x common. Okay, so you can take x common, then you will get here b plus a. On taking x common we have got b plus a, which means you can write this b plus a plus b, same thing, and you can write this x on the other side here. Okay, plus ab. So this is the right hand side of the identity. So that's how we can prove. Okay, So now let me give you another identity. That is what? A plus b whole square is equal to a square plus twice ab plus b square. Okay, plus b square. This is another important identity, very important identity. Okay, now you see how to use this identity. You can use this identity to multiply such kind of polynomial. Suppose twice x plus 1 by again twice x plus 1. Both polynomials are same. Then you can apply this. Now you see, as we know that 2 into 2 is 2 square. 3 into 3 is 3 square. Yes, 3 square. Then 4 into 4 is 4 square. Yes. So similarly, twice x plus 1 into twice x plus 1, definitely twice x plus 1 whole square. Okay. Now compare this a with twice x and b with 1. Okay, and comparing this, what you will get, the result of this, then you will get a square. Here you see a square, so instead of a there is twice x, so you will get twice x square. Okay, plus twice ab. What is a here? Twice x, isn't it? So here this is a, this is b. Okay, so we should have got here a square twice ab. Okay, so what is a here? Twice x, isn't it? A is twice x, b is 1. Okay, so 1 plus b square. Okay, then we have got here b square. So there is, instead of b there is 1, so that's why there must be 1 square. So 4x square plus 2 to the again 4x plus 1 square is 1. So that's how we can multiply such polynomials, sorry, binomials by binomials, okay, of the same kind using this identity. Okay, and this can be used in factorization as well. So let me show you again how to factorize a polynomial. So now you see, let us take this polynomial. This is a polynomial. Okay, let me take this polynomial, 4x square plus 4x plus 1. So let us factorize this. How to factorize this? Okay, using this identity. Now you see, this 4x square can be written as twice x whole square plus, and 1 can be written as 1 square. So we have got these two terms, a square and b square. Okay, now in order to obtain this, let us do 2 into twice x into 1. Okay, so this is what, consider this one as a square, then this will be 2a, this is twice x is a and 1 is b, then consider this one as b square, that is 1 square. Okay, so this should be what, a plus b whole square according to this identity, according to this identity. Okay, so here you see, instead of a we have twice x, so you can write twice x instead of a, and instead of b you can write 1. Okay, 1, so twice x plus 1 whole square. That's how we can factorize such kind of polynomials. Okay, using this identity, a plus b whole square. Okay, so now you see, from here what to do, we know that 2 square is 2 into 2, 3 square is 3 into 3. Similarly, square of this must be twice x plus 1 into twice x plus 1. That's how we can factorize. Okay, so in order to prove this identity, let me take the left hand side first, a plus b whole square. Okay, which can be written as a plus b into again a plus b. Now let's multiply these two. A into a gives a square. Okay, then a into b gives ab. Again b into a is ba. Okay, which also can be written as ab. Okay, then b into b, b square. Okay, now you see a square plus twice, sorry, here ab, ab, so which can be considered as 1ab 1ab. Okay, that's equal to twice ab plus b square. So this is the right hand side of the polynomial, right hand side. Okay, that's how we can prove this polynomial, identity. Okay, so hope you have understood. So now let me give you another identity. Okay, it is similar to this. Okay, so now we have got that a plus b whole square is equal to a square plus twice ab plus b square. Okay, if you have a minus b whole square, then result is same, but change the sign before twice ab only. Okay, only difference is what, this is plus and this is minus. That is the only difference here. Okay, so try to remember the pattern of this form identity, then you can easily remember this, because only you have to change this sign here. Okay, so let me show you how to prove this identity. Okay, so let's take the left hand side first. A minus b whole square, which can be written as a minus b into a minus b. Okay, so now multiply. How to multiply? A into a. Okay, that gives a square. Then minus a into minus b. Okay, this a is positive, so here it is negative, so that's why that's going to be minus a b. Okay, then again minus b into a, this a is positive. Okay, so minus plus minus minus ba. Okay, minus ba, ba and ab same thing, because 2 3s are 6, 3 2s are also 6. Okay, that's why ba ab same result. Okay, then what to do? Minus b into minus b, both are negative, so result will be positive. After multiplication, then b into b is b square. Okay, so here you see, you can consider this one as minus 1ab minus 1ab minus 1 minus 1, that is minus 2. So here minus twice ab we will get. Okay, so this is the right hand side of this identity. That's how our next identity is a plus b whole cube, that is equal to a cube plus thrice a square b plus thrice a b square plus b cube. Okay, so now you see this identity, how to use this identity. Now suppose we need to find the cube of an expression, suppose, or you have to multiply 3 binomials. Suppose we need to multiply twice x minus plus 1 into twice x plus 1 twice x plus 1. Okay, so 3 binomials, then we can write this twice x plus 1 whole cube. Okay, so all the 3 binomials are same. Okay, so now here you see, considering a is twice x, b as 1, you can calculate the product. Okay, cube of this expression twice x plus 1. When a plus b whole cube is equal to a cube plus thrice a square b plus thrice a b square plus b cube, then cube of this must be a cube, that is twice x whole cube. Instead of a, you have to consider this twice x as a and 1 as b. Okay, then plus thrice a cube, a square, what is a here, twice x, then b into b is 1 here, plus thrice a, that is twice x, and b square. Okay, then at the end b cube, that is 1 cube. Okay, so this is 2 cube is 8 and x cube is x cube. 3 into square of 2 is 4, square of x is x square. Okay, then into 1, then 3 to the 6, x into 1 square is 1 plus 1 cube is 1. Okay, so here it is 3 4 the 12 x square, 12 1 the 12, isn't it? So 6 1 the 6 into x, 6x plus 1. Okay, so that's how, in order to multiply, in order to find such products, we can use this formula. Okay, suppose we need to factorize this polynomial. Okay, how to factorize this polynomial? 8x cube plus 12x square plus 6x plus 1. Okay, so this is the question. Factorize 8x cube plus 12x square plus 6x plus 1. So now let me show you how to factorize this polynomial. So 8x cube, this term can be written as twice x whole cube. Okay, because cube of 2 is 8 and cube of x is x cube. Okay, so now you see, and this 1 can be written as 1 cube. Okay, now you see, consider this one as a cube and this one as b cube. Okay, if 1 cube is b cube, then b must be equal to 1, and if twice x whole cube is a cube, then we can say a is twice x. Okay, a is twice x. Now apply this identity. So here thrice a square b, thrice a square, what is a here? Twice x. So write here twice x square plus, sorry, into b, b is here 1, so into 1 plus, then we have thrice ab square. Okay, then again write 3, a is twice x, b square, that is 1 square. Okay, then plus 1. Now you see, this polynomial becomes what? Now it is in the form of a cube plus thrice a square b plus thrice ab square plus b cube. So that's why we can write here, you see, if a plus b whole cube is equal to a cube plus thrice a square plus thrice ab square plus b cube, then we can say a cube plus thrice a square b plus thrice ab square plus b cube equal to a plus b whole cube. So conversely we can write this twice x plus 1 whole cube. Okay, and cube of something, suppose 2 cube, that is 2 into 2 into 2. 3 cube means 3 into 3 into 3. That's why cube of this must be twice x plus 1 into twice x plus 1 into twice x plus 1. That's how we can factorize such kind of polynomials. Okay, so now let me show you how to prove this identity. Now take the left hand side. So what is the left hand side here? A plus b whole cube. Okay, you can write a plus b whole cube. So a plus b whole cube means what? A plus b into a plus b into a plus b. Okay, now you see, or you can write, instead of writing a plus b into a plus b into a plus b, you can write a plus b whole square into a plus b. Okay, a plus b whole square into a plus b. Okay, that gives a cube again. Yes, so now here you see, now let us apply here a plus b whole square formula. So we have already got a plus b whole square is equal to a square plus twice ab plus b square. Okay, so let us apply this here. Then we will get here a square plus twice ab plus b square into a plus b. Okay, so now let's multiply these two. Okay, how to multiply these two? So I have already shown you how to multiply binomial and trinomial. Okay, so first a square into a, that gives a cube. Okay, then a square into b. Okay, both are positive, so here it should be plus. A square into b is a square b. Okay, then what is the next term? Twice ab. Twice ab into a. Okay, twice a b into a. Okay, if you multiply that two, then you will get twice a b into a. Okay, multiply a into a, that is a square b. Okay, twice a square b. So our next term is twice a square b. Okay, then again multiply this term with b now. So if you multiply twice a b with b, then you will get twice a b into b, b square. Okay, so next term is twice a b square. Okay, then again what to do? Now we have to multiply this b square with a. Okay, this b square with a. Okay, let's multiply. B square into a means b square a, which also can be written as a b square. Okay, so next term is a b square. Okay, then again let's multiply this b square with the b. Okay, so let us multiply this b square with b. Okay, so if you multiply b square with b, then you will get b cube. Okay, now here you see this is a square b, this is twice a square b. Okay, their sum must be thrice a square b, so a cube plus thrice a square b. Similarly, twice ab square and 1ab square, that gives thrice ab square. Okay, then at the end there is b cube. So this is the right hand side of this identity, RHS. That's how we can prove this identity. Okay, our next identity is a minus b whole cube, that is equal to a cube minus thrice a square b plus thrice ab square minus b cube. Here you see this is similar to this one, but here you can see this term b is negative. That's why only those two terms are negative where the power on b is odd. Here it is 3, here the power is 1. Okay, so that's the difference in these two identities. Okay, so it's very easy to remember. If you know the first identity, this a plus b whole cube, then you can easily remember the next one, a minus b whole cube. Okay, so as this identity, we can use this identity as well. Okay, I'm not going to show this separately, so this is similar to this one. So here you see how to prove this one. Let me show you how to prove this one. So let's prove this. Left hand side, a minus b whole cube, which also can be written as a minus b whole square into a minus b. Okay, now here you can apply a minus b whole square identity. A minus b whole square, we have got a square minus twice ab plus b square. Okay, now let us apply this. Okay, let us apply this identity here. So applying this identity, we have got here a square minus twice ab plus b square into a minus b. Now again we need to multiply these two polynomials. Okay, so this a square into a, that gives a cube. Okay, then a square into minus b, that gives minus a square b. Here b is negative, a square is positive, that's why it is negative. Okay, now let's move on to next term, minus twice ab. Okay, now multiply this term minus twice ab with a, that gives minus twice. Here you see twice ab into a into a square, so it is twice a square b, so minus twice a square b. Okay, then what will be the next term? So next we need to multiply again twice ab with minus b. Here you see this is minus b. Now we are going to multiply minus twice ab into minus b. So this is also negative, this is also negative, that's why result must be positive, and b into b is b square, so twice a b square. Okay, so our next term is twice a b square. Okay, so now what to do? So now we have to multiply the last term. Okay, b square into a, that is b square a, which also can be written as a b square. Okay, then multiply b square with minus b. B square minus b plus b square minus b gives minus b cube. Okay, hope you have understood up to this. So now a cube, here you can see minus a square b minus a twice a square b. So both are negative, then we have to add the terms, but sign remains negative. So you have to consider this is 1 a square b, this is twice a square b, so thrice a square b. Okay, here you see these two are both positive, so result must be positive. Then you have to add these two. You have to consider this is 1 a b square, this is twice a b square, so thrice a b square, and then minus b cube. So this is the right hand side of this identity. Okay, this is the right hand side of the identity R is S. That's how we can prove this identity. Our next identity is a cube plus b cube, which is equal to a plus b into a square minus ab plus b square. Suppose we have a question, factorize x cube plus 8. Then how to factorize this? Okay, so let me solve this problem. Okay, in order to factorize this x cube plus 8, okay, so we have to write this expression as x cube plus 8 can be written as 2 cube. Yes, because 2 into 2 is 4, 4 to the 8, which is 2 cube. Yes, so now consider x cube as a cube and 2 cube as b cube. Okay, so what we have done here, we have considered x cube as a cube and b cube as 2 cube. Okay, so if we consider like this, then what will be our result? According to this identity, we should have a plus b. Okay, if you consider a cube as x cube, then x should be considered as a, and if we consider 2 cube as b cube, then b should be considered as 2 should be considered as b. Okay, so now, so if you consider x as a, 2 as b, then according to this identity we should have a plus b. So what is a here? X, and b is 2. Okay, so we should get x plus 2. Then next a square, that is here it should be x square. Okay, minus ab, that is x into 2. Okay, and b square, so here we have considered 2 as b, so b square should be 2 square. Okay, so this is our result. Then let me give the final test here. X plus 2, x square is x square, x into 2 you can write twice x, and 2 square is 4. So that's how we can factorize such kind of polynomials using this identity. Okay, So we have another identity similar to this, okay, that is what? A cube minus B cube. Okay, so only this sign is different here, okay, here minus. Okay, so then here you see expressions, the result must be in the same form. A, here B, then A square, AB, then B square. Okay, so difference is here, this should be minus, and here instead of minus there should be plus. Here it was minus, now it is plus. Okay, and this is plus. Okay, only these two sign are changed. Here it is minus and it is plus. Okay, so similar to the previous one. Okay, if we need to factorize this polynomial x cube minus 8, then we have to apply this identity a cube minus b cube. Okay, so here x cube minus 8 can be written as x cube minus 8 can be written as 2 cube. Okay, now consider this x cube as a cube, this one 2 cube as b cube. Okay, then according to this identity we will get here a minus b, that is x minus 2, then a square, that is x square, plus ab, so x into 2, then plus b square, that is 2 square. Okay, so here x minus 2, x square, x into 2 can be written as twice x, 2 square is 4. So that's how we can factorize this kind of polynomial using this identity. Okay, so now let me show you how to prove these two identities. Okay, a cube plus b cube and a cube minus b cube. So now let us prove this identity. How to prove this? So in order to prove this, let us take the right hand side here. A plus b into a square minus ab plus b square. So now let us multiply these two expressions. So how to multiply? You know that this one with this one, then again a with the second term, then again a with the last term, then same thing should be done with the second term of the first polynomial, b with a square, then you have to multiply b with the second term, then again you should multiply b with the last term. Okay, that's how we can multiply. So let me show you one by one. So again let me repeat this. So let us multiply first a and a square, that is a cube. Okay, then a and minus ab, a into minus ab, so we know a into a square, so here result, here is the result minus a b square. Okay, then let us multiply a and b square. Okay, a into b square is simply a b square. Okay, then next term is b. Now let's multiply b with a square, that gives b a square, and you can write b a square as a square b. Okay, a square b. Then let's multiply b with minus ab. Okay, let's multiply b with minus ab, b into minus a b. Okay, this is minus, and b into b is b square, so result is minus ab square. So here we have got minus a b square. Okay, then b with b square, that gives b cube simply. Okay, so now you see minus a square b. Okay, this is plus a square b, so you can cancel these two, and minus ab square plus ab square, cancel these two. So what we have got? We have got a cube, this is a cube, then next b cube plus b cube, sorry. Okay, so this is the right hand side, sorry, left hand side of the identity. Okay. Similarly we can prove a cube minus b cube is equal to a minus b into a square plus ab plus b square. Okay, so proof is same as this one, so that's why I'm not going to show this. Okay,